welcome to my YouTube channel. Thanks very much for subscription. For those who have subscribed, those who have not yet subscribed, please do one thing: subscribe, put on the notification, and we continue to learn. We continue to enjoy the true facts of medicine and health. Today we are going to be looking at drugs which target the coagulation process and blood clotting. So those are antiplatelets. We have thrombolytics and anticoagulants. So starting with antiplatelet drugs, let me say that is my platelet. When this platelet is activated, we are going to have arachidonic acid being released from the membrane phospholipids. So here I'm going to be having arachidonic acid. So this arachidonic acid is going to be converted to prostaglandin H2 by the enzyme cyclooxygenase 1 or COX-1. Then this prostaglandin is going to be converted to what we call thromboxane A2. And this one is going to be released outside of the platelet to cause what we call aggregation of platelets and activation of other platelets. So we have a drug which targets this cascade of reaction, and that drug is called what? Aspirin. So aspirin is a selective and an irreversible inhibitor of COX-1. So this one is going to come and inhibit this enzyme here, so that there is no more arachidonic acid being converted into prostaglandin H2. Then so we shall not have thromboxane being produced, and we shall not have activation of more platelets and aggregation of this platelet. Important receptor on our platelets, and that is the ADP receptor, specifically P2Y12 receptor. And binding of ADP to this receptor is going to lead to a cascade of reactions, which are going to lead to these reactions are going to lead to activation of glycoprotein 2B and 3A. So this glycoprotein 2B and 3A are responsible for activating the fibrinogen binding site, so that we can have the fibrin. This is our fibrin binding this receptor and to the adjacent platelet to cause fibrinogen mediated cross-linking of these platelets. So we have a drug which is going to come and block this receptor. Those are the ADP receptor blockers, and a common example here is a drug called clopidogrel. We have a drug called ticagrelor. So these drugs are going to act by binding on the ADP receptor, blocking it so that the ADP cannot bind there. If ADP cannot bind there, we are not going to have activation of glycoprotein 2B and 3A, so we don't have fibrinogen mediated cross-linking of the platelets. So we are not going to have aggregation of platelets. Another class of drugs, they target directly the glycoprotein 2B and 3A. And examples of drugs we have here, we have abciximab, we have heptifibatide. These ones, they inhibit or they block this binding site on the glycoprotein 2B and 3A. So the fibrin cannot bind here, so we are not going to have the cross-linking. Another important reaction that takes place inside our platelet is the conversion of cyclic AMP to AMP. And the enzyme associated here is a phosphodiesterase. So the enzyme is a phosphodiesterase, which is responsible for conversion of cyclic AMP to AMP. So we have drugs which are going to come, and drugs like diphenhydramine and slosterol. So when these new drugs come, they are going to inhibit the phosphodiesterase enzyme. So we are going to have no conversion of cyclic AMP to AMP. What is going to result? We are going to have increased cyclic AMP, which is going to lead to what? To decrease the calcium. So if you have decreased calcium, we are not going to have no activation of the platelets. Yeah. Having a recap on antiplatelet drugs, we said we have aspirin, which is a COX-1 inhibitor, which is going to block the conversion of arachidonic acid to prostaglandin H2, which is further converted to thromboxane. So we are not going to have production of thromboxane. The drug is aspirin, blocking COX-1. Secondly, we are going to have ADP receptor blockers, and the examples there we have clopidogrel, we have ticagrelor. These drugs are going to bind to the receptor, block it so that ADP cannot bind there. There is no binding of ADP, no activation of the glycoprotein 2B and 3A. Then other drugs we have, they are those ones which are going to inhibit the glycoprotein 2B and 3A. Like drugs like abciximab and the eptifibatide. Then we are going to have a drug which is going to inhibit phosphodiesterase, which is involved in the conversion of cyclic AMP to AMP. Drugs like diphenhydramine and the slosterol. And these drugs which inhibit phosphodiesterase, they have a vasodilation effect. And since they have a vasodilation effect, the common side effect related to them is headache. In our next video, we are going to be looking at anticoagulant drugs.